Hello students, and welcome to our lesson on evaluating and simplifying expressions. This one is going to cover the basics in terms of what order we perform operations in, and then what it means to combine like terms, and in the middle we'll go over some basic steps for distributing and just general simplification of numbers. So to get started, evaluating expressions. To evaluate an expression means to find the value of the expression when the variable is/are replaced by a given number or another expression. So that could mean two things. If we're replacing the variable with a number, we might have something along the lines of x equals 3, but we might also want to plug in an entire expression for a variable. And this is not going to be something we worry about now, but later on when we talk about composition of functions, we might replace x with something more complicated than x. Like say x might actually equal y plus 7z. And that might seem a little crazy, but we have all sorts of different ways that we combine functions and expressions, and eventually we will be plugging expressions in to other expressions. For this lesson though, we're just going to be replacing variables with numbers, again, such as x equals 3. If there is no variable in the expression, then evaluate means to just simplify to a single value. And so that's what we're going to be doing in numbers 1 through 4 at the bottom. There is no variables in those problems, so we're just going to simplify down to a single number. All right, so now to create consistency in evaluating mathematical expressions, mathematicians developed an order in which to perform the mathematical operations. And you've probably seen this in schools as PEMDAS, or please excuse my dear Aunt Sally. It's been slightly updated in recent years to be a G at the front instead of a P, and I'll explain why right now. So G is to simplify any grouping symbols first. And so grouping symbols, you're probably familiar with the first one I'm going to write, which is parentheses. Those are the ones that are curved, but we can also use brackets, which are the ones that are squared on each end. And we also could have all sorts of other functions, which we're going to learn about later in this course, that are used as grouping symbols. So I'm going to write etc. here, but that might mean a square root. It might mean an absolute value, which looks like an 11, but that's an absolute value there. Or it could be any other root, like a cube root. These are all things that we'll learn about in the future and in the 151 course. But parentheses and brackets are the main two we have to worry about, and parentheses used to be what they would use as the title of this grouping, P for parenthesis. But now we use G for grouping symbol. All right, next thing is E for exponents. So we're going to evaluate any exponents. This might be something like 6 squared. We would evaluate to be 36 because to square something means to multiply it by itself. So 6 times 6, 36. Then we're going to perform M and D, which are any multiplication or division that we see. Multiplication or division. And we're going to do that from left to right. The left to right part is less of a rule and more of a guideline, as is all of the order of operations here, but it ensures that we can all get to the exact same answer. Okay, so these are just guidelines to make sure we're all performing things correctly. But the deeper you go into math, the more you're going to learn that there are shortcuts and ways where you can break these rules. So guidelines. All right, and then A and S, we're going to perform any addition or subtraction. So addition or subtraction, and again, we're going to do that from left to right. So now let's actually go ahead and put this into practice. Number 1, it says 15 minus 2 times 5 plus 3. So what you want to do is go through the list that we had right above, G, E, M, D, A, S. So is there any grouping symbols? No, I don't see any parentheses. I don't see any brackets. I don't even need to worry about that. There is also no exponents. We're going to save exponents for when we get down to number 5 down below. We have multiplication in the middle though. And so the first thing from my list I found was this multiplication, 2 times 5 right there in the middle. So I'm going to simplify that to be 10. Then I'm just going to write the rest of the problem around it as it was before. Now we have no multiplication or division left. All we have is subtraction and addition. So now we just work from left to right. So from left to right, 15 minus 10 is 5. We'll leave the plus 3 alone. And then again, from left to right, 5 plus 3 gives us 8. Okay, number 2, we have division. We don't have any grouping symbols or exponents, so we skip those two, but we do have division. So the first thing we're going to do is simplify this division here. Negative 72 divided by 36 is negative 2, and we still have a minus 42 there. So then we just have subtraction left from left to right. Negative 2 minus 42 is negative 44. Number 3, I notice we have a subtraction, an addition, a multiplication, and another addition. So again, no grouping symbols, no exponents, but we can go ahead and jump to where this multiplication is right here in the middle. 4 times 24 is 96. And then we go ahead and rewrite the rest of the problem around it the way we saw it before. Notice I keep all the symbols the same, so the minuses and pluses stay in the same places. The only thing that changed was I multiplied the 4 and the 24. And now that I just have subtraction and addition left, I just work from left to right. So 129 minus 7 is 122, and the rest of the problem is going to stay the same. Then I can add 122 and 96. That is 218. If you're wondering, by the way, how to do some of these problems real fast and in your head like I'm doing, the way I'm able to add 122 and 96 is a little trick. I know 96 is 4 less than 100, so I actually just added 100 and then subtracted 4, because that's the same thing as adding 96. And then for multiplying 4 times 24 earlier, I actually do 4 times 20, which is 80, and I do 4 times 4, which is 16, and I add them together. And that is actually the way we teach you to do it on paper also. But when you're trying to do it in your head, remembering all the numbers all at once can be a little complicated. So never feel bad if you need to pull out a calculator for any of these. But the more you practice, the better you're going to get at it. And you'll probably hear me say this a lot, but calculators really are tools. Make sure you only use them when they are the best tool. But in general, the best tool is your brain. So please flex it whenever possible. All right, last step, 218 plus 32 is 250. All right, number 4, we have division, addition, and subtraction. So I'm going to start with the division up front. 8 divided by 4 is 2. Oops, wrote in the wrong color there. We have 2. And the rest of the problem stays the same. Plus 39, plus 23, minus 53. So now I'm just going to work from left to right. 2 plus 39 is 41. And the rest of the problem will stay the same. Now 41 plus 23 is 64, and we still have a minus 53 there. And so now we subtract 64 minus 53 gives us 11 as our final answer. So now notice, for all 4 of those, no variables to worry about, just basic order of operations. We didn't have to plug anything in. All we had to do was some division, addition, subtraction. Nothing crazy there. Okay, as we go deeper, we'll have more grouping symbols, we'll have more exponents like we're going to see in number 5, and just generally we'll be adding a little bit of layer of complication, but so far nothing too crazy. All right, number 5, it says evaluate negative 36 divided by x squared plus 42 for x equals negative 6. So to evaluate an expression that has a variable in it, when we are given the value of that variable, means to substitute this variable in for x. So since x is negative 6 right here, I'm going to take that negative 6 and put it wherever I see an x in the expression. But we have to be a little bit careful here, because when I rewrite this expression, negative 36 divided by x squared plus 42, what I'm going to do is delete the x and write the negative 6 in its place. But the way I wrote this just now should look wrong to you, okay? Technically, it's fine, but in reality, we have issues because I put this subtraction symbol directly next to this division symbol, and so it's kind of unclear what's actually happening here between division, subtraction, and is the square up here, this exponent, affecting that negative sign? So in order to make things clear, whenever you plug in or substitute the value of a variable for that variable, what I want you to do is always put it in parentheses. So that negative 6 squared, I'm going to write in parentheses the negative 6 on the inside, and that squared is going to go up on top of the parentheses. So notice, it's the exact same thing, but those parentheses change a lot, because now it's clear that this negative 6, the whole thing is being squared. So I'm not just squaring the 6 itself, I'm squaring the negative 6. And when I do that, negative 6 times negative 6 gives me positive 36, which is a big difference than having a negative sign there. Okay, because a negative would then throw off all the rest of our problems. That is by far the most common mistake students will make in these lessons. And so please make sure that whenever you are substituting in for variables, you always put parentheses there. Okay, so parentheses around the -6, then we squared it to get positive 36. All right, now I can do the division. So -36 divided by 36 gives me a -1, and I still have a plus 42 in the back. And so I just add these together to get 41. Okay, notice we were still following the order of operations. Once we got past the exponent, then we did the division before the addition. All right, number 6, we're going to evaluate 8w plus 3p for w equals 7 and p equals 6. So I'm going to do the exact same thing as before. I'm going to write down the expression as it was, 8w plus 3p. But then wherever I see the letter w, I'm going to write the number 7 in parentheses. So I'm going to delete w, and where it was, I'm going to put parentheses with the 7 inside. Notice that if I didn't put those parentheses there, it would just look like the number 87. Okay, so we need the parentheses to make sure all the meaning of the expression still is maintained. All right, now wherever we see a p, we're going to replace it with 6 because p is equal to 6. So I'll delete our letter p and replace it with a parenthesis and a 6 inside. And then now we follow order of operations as before. So we have 2 sets of multiplication here. Whenever you have right here 8w, and then we replace the w with a variable, this means to multiply the 2 things. So we're doing 8 times w, which in this case is 8 times 7. So right here, we don't actually write the multiplication symbol in the middle, but when you have a number up against a parenthesis, that always means to multiply. So we're going to multiply 8 times 7, which is 56. And on the other side, we're going to multiply 3 times 6, which is 18. And we're just going to keep that addition symbol in the middle. Now, all we have to do is add those together, which gives us 74. All right, number 7, we have to evaluate 4w minus 5p squared for w equals 3 and p equals 5. So same steps, I'm going to rewrite my expression the way I see it, 4w minus 5p squared. But now wherever I see a w, I'm going to replace it with a 3 in parentheses. So I'll delete my w and put a 3 there. Wherever I see the letter p, I'm going to replace it with a 5 in parentheses because p equals 5. So I'll delete my p and replace it with some parentheses and a 5 inside. And then now we just follow order of operations as before. So in the last one, we didn't have any exponents, so we went straight to multiplying and dividing. In this one, we do have an exponent on the 5 over here on the right. So we're going to do 5 squared first, which is 25. And then I'm going to leave the rest of the problem exactly the way it was before. Where notice that I just put this 25 in parentheses because up here we had 5 times 5 squared. And so in the next line, I need to be multiplying 5 times whatever 5 squared was, in this case 25. If I do not put those parentheses though, this loses meaning and it would just look like 525, which is not correct. Okay, so we need to make sure we use parentheses quite often in mathematics. Okay, now we're going to finish with some multiplication and then the subtraction. So 4 times 3 is 12. 5 times 25 is 125. We still have subtraction in the middle. And when we do that subtraction, we get negative 113. All right, now we're going to move on to simplifying expressions. And this is going to require a little bit of vocabulary to get going. So simplifying expressions is often referred to as combining what are called like terms. And in order to know what combining like terms means, first we have to know what a term is. So a term is a constant, which would be something like the number 5 or the number 7. Okay, numbers are constants. So a term is either a number, aka a constant, or the product of a constant and one or more variables, such as 5x or 6y or 7z, okay, where we have a letter and a number multiplied together or multiple letters and numbers. Now, along with terms, which are the 5x, the 6y, the 7z, or just a number, we also have what are called coefficients. Okay, and a coefficient is the constant being multiplied by the variable in a term. And so I'm going to underline the word constant right here in red, and then I'm going to draw a little line, and I'm going to point to all the constants in front of the terms in the last line. So when you see 5x, 5 is called the coefficient. 6y, 6 is the coefficient. It tells you how many of that variable there is. Okay, so coefficient, generally looked at as a fairly complicated word by students, but it's a very simple meaning. It's just the number in front of the variable. Okay, but you got to remember that word coefficient. We're going to use it quite a bit. All right, so now like terms, okay, we saw what a term is, we saw what a coefficient is. Like terms are terms that have the same variables raised to the same powers. So a few examples here. We might have 4x plus 3x. Those are like terms because they both have an x to the power 1. We don't write the exponent of 1 when it's a 1, but it's an x to the power 1. We might instead have 3y squared plus 2y squared, where those are also like terms because they both have the variable y raised to the power 2. Okay, so as long as it's the same variable raised to the same power, they are like terms. But something that is not like terms, if you have 3x plus 4y, one of those has an x, the other has a y, that is not going to work. Okay, we would leave those separate from each other because they are not like terms. I always think about it in terms of vehicles. So if you told me that you own a boat and a truck, you would not say that you have two trucks because that would make no sense, right? A boat is a different thing than a truck. We wouldn't add those together to say that you have two trucks because a truck and a boat, they would represent different things. But if you have a truck, a boat, and another truck, we would probably add together the two trucks to say that you have two trucks and one boat. So we would combine the trucks into one group. Same thing with variables, okay? X's go with X's, Y's go with Y's, and they have to have also the same exponent. So X's do not go with X squareds, Y's do not go with Y squares. They only go with things that are exactly the same. The only thing that can be different about them is the coefficient that is in front, and the coefficients matter here. If you were wondering why we introduced that word, well, to simplify an expression means to add or subtract the coefficients from the like terms. So over here, 4x plus 3x, we would say is 7x. 2y squared plus 3y squared, we would say is 5y squared, where I'm just adding together the number in front of the variable. Just like, again, if you have some number of trucks, 5 trucks and 6 trucks, together that makes 11 trucks, where all you do is add together the number, but you leave the term the same way it is. The word truck did not change. All right, so now a quick note. I'm referring to what we're doing here as simplifying expressions, because that's what it is. But simplify, the word simple, will mean a lot of different things as you go through math and, quite honestly, the rest of your life. So the note here is that simplifying expressions will have various meanings as you go through mathematics, and it is sometimes debatable as to what is the most simple way to write an expression. So please follow the methods shown by your instructor and read directions to ensure you are writing expressions in the desired format. Okay, the word simple eventually changes meaning in a lot of different camps. So you got to always make sure you're keeping up with the instructor and doing whatever they consider to be the most simple thing. All right, so now we're going to do some simplifying. And numbers 9 and 10, we're going to introduce the distributive property, which is arguably the most important property that we have when simplifying expressions. But first, number 8. So in number 8, we have 10 minus 3x plus 2 plus 5x. What you're looking for when simplifying expressions is like terms. So negative 3x and 5x are like terms because they both have an x to the same exponent, in this case a 1. And so I can add together negative 3 and 5 to get positive 2x. Think of it, again, in trucks. If you had 5 trucks and I took away 3 trucks, you now have 2 trucks. Okay, you add the numbers, the coefficients, and you leave the variable the same. And along with this, we also have that 10 and 2 are like terms because neither of them have a variable. So they are both constants, which are automatically like terms. 10 plus 2 is 12. So I would say 2x plus 12. Notice that I did not write 12 plus 2x, okay? The reason for that is that this order I wrote it in is called descending order. And descending order means you go down in exponent as the variables change. So x to the power 1 is first, and then the constant comes last. Because x has a higher exponent, in this case a 1, then the 12 does not have any variable, so no exponent. So that's descending order, or we also call it standard form. But the word standard is a lot like the word simplify or simple, where it changes meaning quite a bit. So descending order is the best way to describe this, but it's also called standard form in most cases. All right, number 9. Very important example here. We have 5x minus 9 plus 2, and then parentheses 4x plus 5. So this is the first one we've seen that's a little bit more complicated in terms of the order of operations. By far the most common mistake I see is students want to say that negative 9 plus 2 is negative 7. Not what we're supposed to do here, okay? So you got to break that curse. Do not do that. Instead, we have multiplication that we need to do first. It doesn't look like there's multiplication, but this 2 is actually being multiplied by the set of parentheses it's next to. And so we are going to distribute this 2 to the 4x and the 5, meaning we're going to multiply it by both terms. 2 times 4x is 8x, 2 times 5 is 10, and the rest of my expression, the 5x minus 9 and the addition symbol, are going to stay the same. Most important thing we've done in this lesson, okay? We absolutely have to know how to distribute in order to solve problems and especially to simplify expressions. All right, now it's just like number 8, where all we're going to do is look for like terms. We have a 5x and an 8x. Together that's going to make 13x because I add together 5 and 8. And we have a negative 9 and a positive 10. That's going to add together to be positive 1. So we get 13x plus 1. Notice again, that is in descending order or standard form. Okay, number 10. We again have the distributive property, but it's even less obvious that it's what comes first in this case. And what makes students go a little bit crazy sometimes is the fact that there's a negative sign here, but there's no number attached to it. So it's just minus and then a set of parentheses. Eventually, you get very comfortable with this, but at the beginning, it tends to help students to write an imaginary 1 right next to that negative sign. So don't just think of it as minus and then the set of parentheses. Think about it as a negative 1 times this set of parentheses, just like we had a 2 times the set of parentheses in number 9. So now what I'm going to do is I'm going to multiply a negative 1 into the parentheses. Okay, we're going to distribute the negative 1. Negative 1 times negative 4x is positive 4x squared. Sorry, I didn't say the squared the first time, but negative 1 times negative 4x squared gives us a positive 4x squared. And then negative 1 times 9x gives us a negative 9x. So notice both of those terms change signs when we multiplied by a negative. All right, and then we still have the rest of the problem, 7x squared minus 2x in front. But notice that we no longer have this subtraction symbol in the middle because I already used it on the 4x squared and the negative 9x. So I distributed the negative sign in, and that's how we ended up with a positive here and a negative over here. All right, once you've done that distribution, which again gives students a lot of trouble, that distributing that negative 1, so no worries if that's you as well. But once we've done that distribution, then all we have to do is combine like terms. So we're going to do 7x squared plus 4x squared gives us 11x squared. And we'll do negative 2x minus 9x, which gives us negative 11x. And notice again, descending order, I wrote x squareds before I wrote x's because they have a higher exponent. So standard form tells us to go down in the exponents each time. All right, and so now we've done the hard part. Now we're just going to do a couple applications. So it's also important to be able to model situations. And so that's what we're going to practice right now is modeling. So it says to write an expression to represent the following situation and then evaluate the expression for x equals 13. It says Rita's score is 10 more than 4 times Milan's score. Let x represent Milan's score. All right, so what we want to do is model the situation. So it says Rita's score is. Okay, so first thing I'm going to write down is just Rita's score, because the thing we're trying to represent here is whatever Rita's score is. So now in math, words have meanings. Okay, in the English language, we tend to change the meaning of words pretty often. Not in math though. In math, a word generally means what it means, other than the words simplify and standard. Those ones change. But what I'm going to tell you right now stays the same. So it says Rita's score, so I wrote down the words Rita's score. The word is translates to equals. If I say your name is Kevin, that means your name equals Kevin. Okay, the word is represents equality between two things. So when you see is, you write equals. Then it says the score is 10 more than 4 times Milan's score. So if you're going to do 10 more than something, like if you do 50 push-ups and I tell you to do 10 more, you're going to add 10. So you're going to do 60, because 50 plus 10 would be 60. So 10 more than something tells you to add 10 to whatever the thing was. Okay? So now we got to say what that thing is. It's 10 more than what? Well, it's 10 more than 4 times Milan's score. So 4 times means to multiply. So we're going to do 4 multiplied by, and then Milan's score, it tells us, is represented by the letter X. So I'm going to put an X right there. And that's it. We have now modeled the situation. We're going to do 10 more than 4 times Milan's score. So again, 4 times Milan's score is 4x, 4 times x, which is Milan's score. And then we're going to do 10 more than that, which means to add 10. All right, so now it says to evaluate this expression for when x equals 13, which means that Milan's score is equal to 13. So we're going to say that Rita's score is equal to 4 times 13 plus 10. And then now we follow order of operations. 4 times 13 is 52, and we're going to add 10. So we're going to get 62 is Rita's score. All right, so we modeled Rita's score generally by doing 4x plus 10, and then we found out what Rita's score actually is by substituting in what Milan's score was. Okay, one more. We're going to write an expression to represent the following situation, then evaluate the expression for d equals 10,000 in this case. It says Ted's debt is 3,000 less than half of Mike's debt. Let d represent Mike's debt. So we're going to follow the exact same steps. Ted's debt is what we're trying to model. So I'm going to write down Ted's debt. We could assign a variable for Ted's debt, like the letter T, but in this case, because we're not going to do anything else with it, it's easy enough to just write the words Ted's debt once. All right, then it says is. Ted's debt is something. So we're going to say Ted's debt equals something. Is means equals. 3,000 less. So if 10 more meant to add 10, 3,000 less is going to mean to subtract 3,000. All right, so more means to add, less means to subtract. And it's 3,000 less than what? Well, it's 3,000 less than half of Mike's debt. Okay, so how do we represent half? If 4 times Milan's score was 4 multiplied by x, half of Mike's debt means to divide Mike's debt by 2. So Mike's debt, it says, is D. So we're going to put the letter D, and then we're going to divide it by 2. Okay, half means to divide by 2. We haven't had a lesson on fractions yet. You could also write 1/2 D, or you could write D over 2, and those all mean the same thing. But for right now, I'm just going to write the division symbol. All right, so now we're going to actually evaluate this expression for D equals 10,000. We're going to do 10,000 divided by 2 minus 3,000, where order of operations tells us to do the division first. So 10,000 divided by 2 is 5,000. And then we will subtract 5,000 minus 3,000, gives us 2,000. So we can say that Ted's debt is 2,000. All right, and that is the end of our lesson on evaluated expressions. Thank you for joining me, and see you guys next time.